Hello. Okay, guys. I hope we can start the session. So, very good evening, guys, everyone. Yeah, very good evening, guys. So, any doubts from the last session? Is everything clear? Yeah, very good evening, Sana, Alam, Akshay. Okay, no doubts. Yeah, good evening, Soumya. Okay. So if it's clear, let's try to proceed with today's session. Today, let's try to focus uh, more upon the topics of measures of dispersion, sample, as well as population. But before proceeding with those things, let's have a quick recap on yesterday's session. Okay. So whatever the session that we discussed yesterday, based upon the topics measures of central tendency, we'll have a quick discussion on it. So when we are referring with a concept measures of central tendency, we are having three options available: mean, median, as well as mode. Guys, I hope you can able to see my screen, right? Okay, right. So what is mean? Average. Mean itself is nothing but average. It's nothing but sum of all observations by number of observations. And this in itself, we consider it as average. And when you are referring with median, it is going to be the exact middle value available in the data set. In case, yesterday also we discussed about it. In case if you are having some data points, odd numbers, the exact middle value is your median. If in case you are having some even numbers, then the average of the middle two values, you consider it as median, 3.5. And in the same way, we discussed about a topic called mode. Mode itself is nothing but most frequently repeated value available in the data set, right? So based upon your requirement, you just need to select whether you need to go with mean or whether you need to go with median and whether you need to go with mode. Okay. So once again, I'm just taking a reference out there. Whenever we are talking about the topic measures of central tendency, we are having three options: mean, median, mode. Mean itself is nothing but sum of all observations by number of observations. You can even consider it as average. When you're proceeding with median, it's nothing but it's the exact middle value available in the data set. So in case if you're having odd numbers, exact middle value. In case if you're having even numbers, the average of middle two values. And the one important thing that you need to remember is first thing first, you need to sort the data. Once after sorting the data, then only you can start performing your median concept. And mode, obviously, it's the most frequently repeated value available in the data set. So, uh, maybe 10-15 minutes little early, Vijay. Okay. Actually, the thing is, I'm not feeling well from yesterday. So, little cold, little fever is there. So, maybe 10-15 minutes will wind up in well. Okay. So, measures of central tendency, these are the three concepts available. Okay, okay, no problem, Vijay. Yeah. So these are the three options available, measures of central tendency. So just down there, we'll be focusing on one more topic called sample and population. sample, population. So first thing first, let's try to understand what is sample and what is population. So once we are pretty much clear with what is population and what is sample, let's try to focus on what are the available sampling techniques available. Okay. See, whenever we are referring with the concept population, it's nothing but it's a whole thing, guys. Okay. Whatever the data that you are having, the entire data set, you consider it as population. This entire big circle, you can even consider it as population. And a small portion inside that population, you consider it as sample. And there you can try to consider taking multiple samples of them. Okay. A small portion out of your population, you consider it as sample. And you can just take multiple samples too. So, see, I hope you got the basic understanding what is population and what is sample. Population itself is nothing but everything, entire data. Sample itself is nothing but a small portion in that data that we consider it as sample. See, assume it in a simple way. You are having a bucket which consists of multiple balls. Okay, there's a bucket and you are having multiple balls available in it. And you consider it as population. And what is population? All the balls available inside the bucket, you consider it as population. And now, if you are just taking a small portion of this population, you're just putting your hand inside that bucket and you're just coming up with 4 to 5 balls in your hand. Now, this small portion of population itself, you consider it with a name sample. Once again, I'm repeating, all the balls available inside that bucket, you consider it as population, and a small portion inside that bucket that you are going to take extract, you consider it as sample. I hope everyone clear. You got a basic understanding what is population and what is sample. Right. So when we are referring with this concept called population, it's an entire data, but a small portion of it, we consider it as sample. And the main thing that what you need to understand is why we need to take sample out of your population. First thing that you need to understand is when you're performing some analytic tasks, if you are going to perform some analytics on data, always remember it's always best practice to go with sample gaze rather than going with population. You might get a doubt. So why we are not proceeding with population? Why we are supposed to go with sample? Simple. Sample itself is nothing but more cost effective. At the same point of time, storage complications will not. Once again, I'm repeating. Population, if you're performing your analytics on your population, that itself is going to be a very costly process. But if you're going to perform your analytics on a sample, this itself is going to be something more cost effective. And one more important thing, try to consider it in tool specific knowledge. Say, for example, you are having a population which consists of close to 5 million rows, 5 million records. It's nothing but almost 50 lakh rows are in there. Now, if you are going to extract all, if you are going to take input of all, sorry, could I start in the, yes, Lakshmi, just now the session started. Okay. When you're considering population, what usually happens is 5 million rows are there, 50 lakh rows are there. If you are importing all the 50 lakh records into the tool, maybe memory and storage complications comes into picture. Memory, storage, complications will be there. If memory or storage complications are there, obviously performance will degrade. Yes or no? Performance will degrade. But if you are going to take a small sample out of your population, and based upon that sample, if you are going to perform your analytics, say for example, 5 million rows are there, 50 lakh rows are there, no problem. I'm just taking a small portion out of your population. Assume that 1 lakh rows you are extracting. And on this 1 lakh rows, you are going to perform your analytic tasks. And based upon that analytic task, you are going to predict for your entire population. And this is how it usually works. See, for your easy understanding, I'll give you one simple example. Why performing analytics on sample is something more interesting and more effective compared to population. Let's take a simple example, exit polls. See, whenever elections, voting, all these things are there, exit polls will. Before even results have been declared, exit polls have been conducted. Yes. Now, when you're, if you want to use hold, and if you want to use hold in that, yes, yes, Nikita, exactly. See, whenever we are considering about exit polls, just tell me one thing. You are going to perform your analytics. So, for example, you just want to know which party is going to lead, which party is going to win in this particular constituency. You will go to each and every house in that particular locality, or you'll just go to some random location and you'll do a quick survey out there. Guys, you just want to know which party itself is going to lead in that particular constituency. You'll go to two, three random localities and you'll do a quick survey out there, or you'll go to each and every house in that constituency and you'll do the survey. Only random localities, right? Why you're not going with each and every house in that constituency? In constituency, there are multiple localities available. If you are considering, I'll go to each and every locality and I'll try to perform some survey. First thing first, it is time consuming. And second thing is it's very costly process to perform your analytics, to perform your survey, to perform your insights. You will be ended up wasting so much of time. Some months of time you are going to waste. At the same point of time, it's a very costly process. Why it is we call it as a costly process? First thing first, resources need to be there. Resources in the sense human resource, right? Human resource need to be there. That many individuals need to there to perform the survey. And if they are going, we need to consider taking shelter, considering food for them. Yes or no? It's going to be a really costly process and time consuming process. And so performing analytics on your entire population itself is little disadvantage. But instead of performing survey, instead of performing analytics on entire population, you are going to pick some random 5 to 6 localities and you'll be getting some results. After your analytics, you will be getting some results. Now, based upon that results only, these news channels will publish that maybe this particular party is going to win after elections. Yes or no? And in most of the cases, the results are going to be exactly same, similar. Agreeing with this point, guys, everyone? Based upon your sample survey on this particular part, what are the analytics that you are trying to fetch? And those analytics, those results are going to be almost similar for your entire population data also. And that is the reason we are going to perform our analytic tasks on sample rather than performing it on a population. I hope it's clear till now. Any doubts, guys? Is everything clear? Can I proceed further? Okay, right. Right. Now, when we are referring to this concept, extracting sample out of your population, we'll be dealing with sampling techniques too. Sampling techniques. So what are sampling techniques? A technique that you are going to utilize to extract a sample out of your population. Simple thing, you're having entire data, you consider it as a population, and you're just going to take a small sample out of your population. Okay, you're having entire data and you consider it as population. And you just want to take a small sample out of your population, and that is we call it as sample. So to take a small sample out of your population, you will be having different techniques also available. There are multiple techniques available to extract a small portion of data as a sample from your population. And what are the different types of sampling techniques available? Let's try to have a discussion on it. So when we are referring with a concept, different types of sampling techniques, we are having something called simple, random, sampling technique. And the other one we call it as clustered sampling technique. Stratified sampling technique. Systematic sampling technique. Even you are having a type of technique called biased sampling technique. So different techniques are there. Yes. Yeah. See, when you are working with sampling techniques, what is the type of technique that you are going to utilize to take a sample out of your population? Once again, I'm repeating, sampling technique itself is nothing but what is the type of technique that you are going to utilize to extract a sample out of your population. So to understand how to extract sample, we are dealing with sampling techniques available. So first thing first, let's go with a sampling technique called simple random sampling technique. Simple random sampling technique. Now, what is the simple random sampling technique? See, take a simple case. Just now we discussed about an example called exit polls. What is going to happen here? There is a constituency. There is a constituency. And you just want to do a quick survey, which party is going to win, which party is going to lead. Now, it's not the case like you will go to only this particular locality or this particular area and I'll do survey. Randomly, randomly, you'll go to 4 to 5 localities in that population. And from there, you will try to do a survey. Based upon that some survey results, you are going to assume which party is going to lead. That means based upon your sample result, you are going to understand, you are going to predict, you are going to forecast which party is going to win for that entire population. Yes or no? Is that okay? We can assume this particular type of example as simple random sampling technique. Guys, agreeing with this point? Or else take one more simple example. Take a small bucket, multiple color balls are. Okay. Even if you're not satisfied with exit polls example, try to consider this example, a very simple. So for example, there is a bucket, multiple color balls are in there. In this bucket, green, white, different color balls are in there. Now, say for example, blindfoldedly, okay, blindfoldedly, you're just putting your hand inside the bucket and just coming out with 5 balls in your hand. Once again, I'm repeating. Blindfoldedly, you're just putting your hand inside the bucket and coming up with 5 balls out in your hand. Among those 5 balls, among those 5 balls, see, first thing first, is that okay? We consider this is your population, all the balls available inside this bucket as a population, and these 5 balls as a sample. Guys, everyone, clear? All balls which are available inside the bucket, you consider it as population. And the 5 balls which have been there here, we consider it as sample. And you're just putting your hand inside blindfoldedly. Why I'm telling blindfoldedly? It's a random sampling technique. If you're opening your eyes and closing up, it's something like biased. You might show some bias. But here, randomly, without opening your eyes, you're just putting your hand and coming up with 5 balls in your hand. So 5 balls are nothing but sample. Now, out of these 5 balls, 4 balls are been there with white color, and one color is with orange color. Now, what you are going to conclude? Maybe, maybe majority of the balls available inside this particular bucket is also with white color, right? Whether you can draw these kind of conclusions or not. See, you are taking a sample. Based upon this sample analysis, you concluded that majority of the balls have been there with white color. Based upon this particular analytics only, you are going to assume, you are going to understand majority of the balls inside this particular bucket is also going to be there with white color only. Why? Because in your hand, 5 balls are there. In 5 balls, 4 balls are with white only. So most of the cases, all the balls in that bucket is also majority will be available in white color. Clear? Any doubts in this, guys? Simple random sampling technique. Okay. Now, there is one more type of sampling technique called clustered sampling technique. Clustered sampling technique. Clustered sampling technique itself is nothing but, again, you are having your entire population and you are just going to create multiple clusters inside that population. Cluster 1, cluster 2, cluster 3. Based on your requirement, you can cluster the data. So say, for example, um, during COVID scenario, COVID situation, anyone heard about this COVID cluster? COVID cluster. In news channels, they used to tell, right? What does this COVID cluster mean? There is a locality where majority of the COVID cases have been there, right? Majority of the individuals in this particular locality are affected with corona, COVID. That means if you are mentioning that particular cluster as a COVID cluster, we can take some good practices, best practices. So for example, a random Zomato or Swiggy guy is going to deliver some food. We are we are providing some precautions, right? Yes, exactly. Highly affected area. So for example, we are just providing some precautions to the delivery partners. You just need to wear a mask, you need to sanitize your hands. Or say, for example, any individual who is coming out of that COVID cluster, right? We are stopping them. Some precautionary measures we are going to handle. There you are going to cluster the data. So on what basis you want to cluster the data based on a condition, it's up to you. But whatever the population that you are having, out of that population, yes, exactly. If you are grouping, you are segmenting, and you're dividing, partitioning, you consider it as cluster. And how many clusters you want to create, it's up to you. Based on your requirement, you can just create multiple clusters and you can just start working with it. Okay. So these sampling techniques, everything again practically we'll be doing is in Tableau also these are options are available. So let's try to slowly understand each and every. This is clustered sampling technique. And so for example, the third type of technique that we are having is stratified sampling technique. Stratified sampling technique. So what does this stratified sampling technique mean? Stratified sampling technique itself is nothing but separating, segmenting, stratifying, dividing. So for example, you are having a data set which consists of a column called gender. Okay. You are just going to segment the data. You are just going to divide the data. You are just going to stratify the data based on gender. Male as one sample, female as another sample. What my point? What I mean to say? Whenever you are working with a type of sampling technique, stratified sampling technique, what usually happens is you are going to divide something. You are going to separate. So, for example, if you are working with a data population, if you just want to divide it, male as one sample, female as one sample. There might be some use cases where you need to perform your analytic tasks only based on one particular sample. So, for example, you're working with something called healthcare data. In healthcare data, you just need to be something based on specific relating to gender, based on male and based on female. So based on that, how you're going to perform your analytic tasks, you're just going to stratify it, and based on that samples also you can start with. Okay. You are having one more type of sampling technique called systematic sampling technique. So what does the systematic sampling technique mean? So for example, in an order, in a systematic way, you are going to create a sample. So for example, I'll give you one simple. No, only not only two division, multiple divisions you can do. No problem. Systematic sampling technique itself is nothing but you are going to order the data. You are going to create a sample based upon some ordering condition, guys. So for example, just go back to the same COVID scenario, COVID situation. Uh, there will be one person. So for example, if you just want to go to DMart, okay, or any shopping mall. In COVID scenario, I'm talking about. There is a person who constantly check the vitals, right? Whether you're having fever or not. What is the pulse? They'll just be there to monitor these things. Based upon that, they'll just allow you inside the mall. Yes or no? Now, take a simple case. You are taking an example, DMart, and you just want to take a sample out of your population. Say, for example, you just want to perform a survey on all the customers who are entering into DMart between 10 a.m. in the morning till 11 a.m. in the morning. So based so based on this particular time from 10 a.m. to 11 a.m., 1 hour duration. So for example, 100 customers are entering into DMart. Assume that 100 customers are entering into DMart between this 1 hour time gap, 10 a.m. in the morning till 11 a.m. in the morning. Is that okay? We consider all these 100 customers as your population is. Now, now, there one person will be there who just wants to check the vitals. So, for example, the fever, whether you're having fever or not. What about the pulse monitoring? All those things, just they want to check. So now, what usually happens is you are providing some clear instructions to that person not to check fever status, not to check the pulse monitoring for every customer who is entering into DMART. You're just mentioning that you're just providing something called check every 10th customer detail. That's it. You just need to check every 10th customer. That's it. That means that, for example, if you are taking consideration all 100 customers are entering into DMAT between 10 a.m. and 11 a.m., and this we consider it as population, what you are going to do is you are going to check the vitals for the first person, first customer. Sai Kiran, what happened, Sai Kiran? You're just annotating something, I guess. See, after one, you just want to provide some value. You're just skipping the next 10 individuals and you're going to check the vitals for the next 10th customer. That means 11th. And again, that person is not checking fever status, everything for remaining next 10 student, next 10 individuals, and is going with 21st. And in the same way, 31st. So, like that, for all the 100 individuals, 100 customers, if you are going to take a sample, the sample size itself is something we are assuming it as n equals to 10. And the population size itself is 100. Now, assume that this is your sample and this is your population. Population size is 100, sample size is 10. Why? Because they are just checking every 10th customer. That's it. Now, okay, no issues, Cyclone. Now, here what I'm trying to conclude is if you are going to check every 10th customer details, the sample size 10 is there. Now, out of these 10 individuals, assume that 8 individuals are having fever. 8 individuals are having fever. And remaining 2 individuals, no fever. And this analytics itself is something that we are performing in sample or population case. Where is everyone? The analytics that we perform is on sample or population. It's on sample, right? Now, based upon this particular sample result, based upon this particular sample result, is that okay? We can predict what is going to be happening in population case also. That means you can just consider that, acha, out of this sample, 10 customers or 10 individuals, almost 8 individuals are having fever. Maybe inside DMART also, out of those 100 individuals, maybe 80 individuals are having fever. 80% of the individuals, 80% of the population is also having fever. Yes or no? So that is the reason understanding and performing analytic tasks on a sample is way simple, way cost effective. It's more easier option comparing with population. And that is the reason we are always going and we are always interested to perform the analytic tasks on sample, not on a population. Till now, I explained you complete these things based on a general use case scenarios only. Try to consider it with real time tool specific thing. What usually happens in tool specific real part is if you are going to take input of entire population data, the tool might become little slow. Why? Because it will take so much of storage memory automatically, performance will degrade. So multiple complications will be there, obviously. But here, while you are proceeding with this concept, sample, you're just going to extract a small sample out of your population. and you're just working. And based on that, you can just perform your analytics. Exactly, Likita. Okay. That means you are going to understand, you are going to take an assumption what is the case for entire population, just utilizing based upon your sample data itself. I hope it's clear till now, everyone. Right. Now, in the same way, you are having one more type of sampling technique called biased sampling technique. Biased sampling technique itself is nothing but you are going to take a sample out of your population based upon some bias. Wantedly, you are going to take a sample out of your population based upon some bias. So, for example, you just take a simple case, guys. You are going to perform a quick survey on college students. Okay, there is a BTech college, engineering college, and you just want to perform some analytics survey on entire college, 4 years. Now, the simple requirement here is what you need to do is if you are doing a survey, if you're see, okay, take let's make it a little more interesting. Take a simple case. The survey question itself is whether the college is providing you a good infrastructure or not. The college itself is providing you the all these things that you are interested to have or not. So, for example, instead of performing a survey on all 4 year students, you are just performing a survey on only first year students only. Is that okay? We consider it as bias? Obviously, there is some bias there. Based upon first year students only are just performing some survey so that you will get some output based upon your requirement. Why? Because you want to get some kind of output. Based upon that output, what you are expecting, you are getting the same answers. So for that, to get the same answers out there, you are performing a bias. Okay. Bias sampling is nothing but wantedly, you just want to take a sample out there and you're just going to perform some analytics on it. So there might be some scenarios also where you need to consider taking bias sampling technique, but rarely. Will not go with this type. But in general, in a nutshell, what is sample, what is population, what are sampling techniques? Let's have a quick idea about it. Sample itself is nothing but you are just going to take a small sample out of your population. Population itself is nothing but whole data, entire data. Sample is nothing but a small portion inside that population. And to extract a sample out of your population, you're having something called sampling techniques. And the first type of technique is called simple random sampling technique. Randomly, you're going to take a sample out of your population without any bias. Clustered sampling technique itself is nothing but you are going to create some clusters based on your population. Stratified sampling technique is nothing but you are going to stratify, you're going to divide the data based on the requirement. Systematic sampling technique itself is nothing but you are going to take a sample out of your population based upon some ordering condition, systematic flow. And bias sampling technique itself is nothing but based upon some bias, you are going to take a sample out of your population. And these are the different types of sampling techniques available. And there's what sample as well as population. So I hope any questions that have been coming on this concept in an interview, I hope you can able to explain these things, guys. Whether you can able to explain these concepts. If they're asking what is sample, what is population, what are sampling techniques available. Okay, right. Nice, nice. Perfect. So in your own words, just make a note of it, guys. Whatever the things that we discussed till now, just have a note in your own words. Mm. I'll explain, Ramya. I'll explain. See, clustered is nothing but you are going to partition the entire population based on some requirements. You're clustering it, dividing it. Stratified systematic is nothing but stratified, you're separating based on some unique data. Gender male as one, gender female as the other. Systematic is based upon ordering condition. Okay, every 10th number, every fifth number, you are going to create a sample. I'll explain. For all these things, we're already having functions, Arjun. We're having functions for it. We can deal with it. I'll explain that part, okay? While we are going with Python. Just try to have a note, please. Done, guys, completed. Online participants completed. There might be a cases where the decision might go wrong. That is the reason what we usually do is we will try to take multiple samples out there. Based upon that samples only, you are going to evaluate for your entire population. Based on one single sample only, you are not going to take some analytics part. We are going to take 4 to 5 samples out there, random samples or systematic samples. Based on that 4 to 5 samples, what are the output that you are getting? Based on that output, you are going to assume for your entire population also. Okay. Right. See, that is the main common problem. Obviously, it's a good question. What usually happens is if you are taking one sample, based upon that sample, every time whether your population result itself is going to be validated or not, you'll get it. Maybe most of the cases it will not, right? So, for example, there are some considerations. So, for example, exit polls is there. They'll mention something like you will get only this party is going to lead, but maybe the other party is also going to, apart from the survey results, the other party might be in a leading position. Why? Why? Because sample result itself is something not satisfactory. Okay. There might be cases where results are going to be misleading also. What I mean to say is instead of taking only one sample, try to take 2 to 3 samples or 4 to 5 samples. Try to perform your survey. Based on that 4 to 5 sample survey, still you are getting that same output. Then you can consider majority of the cases for population, you will be getting the same result also. Okay. So now let's try to consider with one more topic, measures of dispersion. Yesterday we discussed about measures of central tendency, right? Mean, median, mode. So today, let's try to focus on a concept called measures of dispersion. Is there any chance of outlier in sample? Yes, obviously. There is a possibility of having outlier available in your sample too. So again, we need to cross-check those things by putting some conditions again. See, when you're working with measures of dispersion, first thing first, what we need to understand here is how much data itself has been dispersed, how much data itself is being deviated. So these are things that you'll be considering here while you're working with measures of dispersion. Basically, you're having two options available. One is variance and the other one is standard deviation. So when you are considering a concept called variance, what usually happens is you'll talk about what is the spread of data. What is spread of data? And when you're working with standard deviation, this itself will explain you how much deviated a value is from average. Okay. So for example, let's have a quick consideration. You are having a data set, a normal distributed data. Okay, I'll explain, no problem. What is this normal distribution, everything in detail. When you are talking about a normal distributed data, whatever the data that you are having, this entire marking positions that what you are having, in between this curve, you call it a spread of data. This entire data itself, we call it as spread of data. And this, how much spread is that? This you consider it with an option called variance. But what is standard deviation? So for example, if you are going to take an average value of this particular data, so for example, somewhere you will be getting an average value here, and you will be having deviations like this. First standard deviation, second standard deviation, third standard deviation. If you are talking about this particular value, what does it mean? One standard deviation is between this particular range, average. From average, two standard deviation itself is present. From average, three standard deviation itself is there. So how much flow, how much deviation itself has been provided between these data points, numbers, everything itself is provided here. And we call it a standard deviation. C, spread of data. Whatever the data that you are actually having, and you just want to understand that entire spread, you consider it as variance. But when you are considering how much deviated the value is between from average position, is it one number, is it two number, or is it three number? How much deviated the values that you consider it as standard deviation result. And standard deviation itself is nothing but your square root of your variance. Okay, what are the variance that you are having? If you are going to perform square root of variance, you consider it as standard deviation data. So basically, if you are more interested to understand what is the central element, what is the middle value, what is the central value available in the data set, then you will be going with a concept called measures of central tendency. That means mean or median or mode. But if you are more interested to understand how much spread is their data, what is the deviation available for between the data points, then you consider going with a concept called measures of dispersion. And in measures of dispersion, you're having two more concepts called variance as well as standard deviation. And when you are proceeding with a concept called standard deviation, again, the result itself is something. Standard deviation itself is nothing but square root of your variance. That means whatever the value that you are getting for variance, it's nothing but square root of variance. If you're performing, you'll get something called standard deviation result. And remember, guys, when you're going with this option standard deviation or variance, again, you are going to perform it based on sample, not based on population. Always remember, whatever the statistical computation concept that you are going to work with, you are not working based on population. You are only going to work it based on sample itself. That means you are going to extract a small portion of data first, and based upon the small sample portion, you are going to perform your analytic task. And this is how usually the concept works, case. Clear? So I'll try to explain these things while you are going with some functionalities part in tomorrow's or day after tomorrow's session. While we are performing the calculations for sample as well as variance, you'll be proceeding with something called n minus 1 in denominator for standard deviation. Why we are proceeding n minus 1 is whatever the sample size that you are having minus 1. Okay. Why we call it with an option called Bessel's correction. Bessel's correction. This is the another concept that we need to focus on. So tomorrow, or most probably day after tomorrow, we'll be going with a topic called distributions topic. So there I'll try to explain this topic one more time. How to approach variance and how to approach standard deviation. Is there any condition like sorting on the data of a standard deviation? And sorting the data for sorting in a sense? Yes, yes, Ramya. We are going to use these concepts in Python. And means you're considering your sample. Yeah. No, no, not required. Directly you can start performing. First, whenever you're performing your frequency distribution, then you will be ordering it, and later part not required once you're performing your calculation. Just make a note of these things, please, in your own work. Uh, Tomorrow's session again, WebEx only, Sudha. I think tomorrow's class will also be. That's okay. It's more clear in WebEx. Okay. Yeah, tomorrow from tomorrow we'll be proceeding with WebEx only. Okay. So offline participants again tomorrow you can come to a classroom. Okay. So tomorrow again the session itself is something conducted in offline mode only. So guys, tomorrow, sir, in the Zoom, can you mention the challenges we completed in the Wednesday? Yeah, yeah, Ramya, you can. Okay. Definitely, if any, in case any um, projects or any competitions that you have worked with, definitely I'll suggest you to put those things in your resume too. Definitely it will work. Okay. Any doubts, guys, from today's session? Okay. So no doubts. Type of role. See, you can apply for job opportunities, data analyst, business analyst, Power BI developer, SQL developer, or you can apply for some job roles like Tableau related roles or even Excel related roles. Okay, there are some opportunities with role names called data engineer. That's a different role altogether, but the same with the same requirements of tools and technologies they'll provide. Okay, so you can utilize and you can apply for these job opportunities. And what usually happens is even they'll provide something called data analyst or business analyst in the back end. The profiles, the job description, tools, and these things will be a little different. Okay, so that is the reason. Utilize those tools and you can start it. Soumya, n minus one is nothing but it's nothing but Bessel's correction. When you're taking for exact input, exact accuracy output, if you want to get, what you'll be doing is you'll be trying to remove minus one. You'll be subtracting minus one out of your sample part and you'll be working on it. So that you'll get that exact accurate data. So we'll discuss about. It's a little different, Ramya. Why? Because database admin and the SIMs, you need to be even professional with DCL, data control language, grant as well as review. Okay, clear guys, everyone? So let's try to wind up the session today. So tomorrow, let's try to focus on some distribution concepts available. And tomorrow again, we'll have a discussion on outlier topic one more time. So still any concepts? Okay, mostly we'll be going with distributions topic is. Okay, I'll suggest you to focus on the topic one more time. Based on that, we'll proceed. Okay. So okay then, guys, everyone. So let's connect tomorrow again. So, okay, then bye, guys, everyone. Good night. Yeah, thank you, Sana. Okay, thank you, Alam. Good night, Anusha. Bye, guys, everyone.